Do you feel the vibe?
Hello everyone! Another day to live, another day to love, another day to love, and another day to learn. So for today's discussion, we are going to learn about quadratic inequalities. In this lesson, you are expected to first define quadratic inequalities, and second is to illustrate quadratic inequalities. Previously in our discussion, we know that the standard form of a quadratic equation is ax squared plus bx plus c is equal to 0, where a, b, c are real number coefficients in which a is not equal to 0 and x is the unknown variable. So for quadratic equation versus quadratic inequalities, we need to make sure what's the difference between these two. So, unlike the quadratic equation that has an equal sign, quadratic inequalities use inequality symbols like less than, greater than, less than or equal to, and greater than or equal to. Let us now discuss and define the quadratic inequalities. Quadratic inequalities are composed of polynomials with the highest degree of 2. The following inequalities are the standard form of quadratic inequalities with different inequality symbols. So for example, instead of writing the equal sign, we have here the inequality symbols. So we have ax squared plus bx plus c is less than 0. Another, we have ax squared plus bx plus c is greater than 0, or ax squared plus bx plus c is less than or equal to 0. And lastly, we have ax squared plus bx plus c is greater than or equal to 0. As a review, we all know that in the polynomial ax squared plus bx plus c is that ax squared is the quadratic term, bx is the linear term, and of course c is our constant. So, quadratic inequalities may not have linear or constant term as long as the highest degree of the polynomial is 2 and uses an inequality sign. So, let us try to identify a quadratic inequality by simply illustrating quadratic inequalities. So, for example, is that we need to simplify and identify which of the following is a quadratic inequality. If the equation is a quadratic inequality, we need to transform it into the standard form. For number 1, we have 4x squared plus 3x plus 1 is less than 0. So for our answer, we can say that this is a quadratic inequality. Why? Because the highest degree of the polynomial is 2 and uses the less than sign. As simple as that. So let's take a look with number 2. For number 2, we have 8z minus 12z is equal to 0. So performing the operation and combining the two like terms, we have negative 4z is equal to 0. For number 2, we know that this is not a quadratic inequality. But why? Because the highest degree is only 1, which is a linear, and it uses an equal sign. Remember that in quadratic inequalities, the highest degree of the polynomial is 2 and uses an inequality sign. Okay? So for number 3, we have 14y minus 9 is greater than or equal to negative y squared. First is you need to perform and transform negative y squared to the left side of the inequality or the given. So we have from negative y squared, we have y squared plus 14y minus 9 is greater than or equal to 0. So for our answer, this is a quadratic inequality. Why? Because the highest degree of the polynomial is 2 and of course it uses an inequality symbol of greater than or equal to. For number 4, we have 70 raised to 9 plus 28 is equal to 0. So our answer is simply not a quadratic inequality. Why? It is not a quadratic inequality because the highest degree is 1, which is linear and uses an equal sign. Okay, so last example is that we have for number 5. So we have 2d squared plus 5 is greater than 11d squared minus 22. First is you need to make or transform the given values. So we have 11d squared minus 2d squared minus 22 minus 5 is greater than 0. Next is, it happened actually because we multiply all the inequality by -1 so that we can cancel out the negative sign for 11d squared. Remember that every time that we transform a term, the sign changes. Okay, so hindi ko na siya pinakita, pero if you're going to try it, all you need to do is to multiply all of the given by -1. So the result is 11d squared minus 2d squared minus 22 minus 5 is greater than 0. Next is to combine like terms. So we have 11d squared minus 2d squared, that is equal to 9d squared. And negative 22 minus 5, we have negative 27. So we have 9d squared minus 27 is greater than 0. So to simplify, we simply need to divide them by 9 since 9 is their GCF. So we have 9d squared minus 27 greater than 0 divided by 9 is equal to d squared minus 3 is greater than 0. So for our answer is that this is an example of quadratic inequality. Why? It is because the highest degree of the polynomial is 2 and it is still acceptable even though there is no linear term. Remember what I told you earlier, that quadratic inequalities may not have linear or constant term, but as long as the highest degree of the polynomial is 2 and it uses an inequality sign, you can consider that as quadratic inequality. So that would be the end of our discussion for defining and illustrating quadratic inequalities. For our next video, we are going to talk about how we solve quadratic inequalities. Thank you for listening and God bless.